Okay, so today I'm going to help you guys work through these type of problems. So if I give you one of these, so your hydrogen ion concentration, you should be able to figure out the others. I'm also going to do it with two different calculators. This one will work the same as a graphing calculator. So if any of your calculators have two or more spaces, so this has a line up here and it'll have another line for digits down here. So any calculator that has two or more spaces will work the same. And you'll type things in different though if it only has one line for numbers. So I'm going to start by working through the problems from the study guide. So study guide questions in 16, the essential practice 16. And then I'm also going to do the you do problems from the official day 2 PowerPoint. All right, so when I work through these, I'm going to keep coming back to these equations, but I always set it up in the box format. That way I know which equation to use. So in our first problem, it tells us our hydrogen ion concentration is 1 times 10 to the negative fourth. So when we set these up, hydrogen ion concentration goes on top, hydroxide's to its right. Below hydrogen ion concentration is the pH, and below hydroxide ion concentration is pOH. So for all these problems, I'm going to have it set up in the box so we can go ahead and find the other three. All right, so I have two directions I can go. I can go from left to right, or I can go from top to bottom. So I think going from top to bottom is a little bit easier, so let's start with that one. So when you go down, you need to step on the log, which means you're going to take the negative log of the concentration. So I'm going to use this equation here. Oh, I didn't write that one down. How convenient. So to get pH, so if you do the negative log of the hydrogen ion concentration. To get pOH, same thing, we're going to be going down, and so it'll be the same equation. You'll step on the log, so we'll do the negative log of the hydroxide ion concentration. All right, so we were given our hydrogen ion concentration. We're going to get down to pH, so we're going to step on the log. We'll take the negative log of this concentration. So let me go ahead and write that out for you. pH equals the negative log of 1.0 times 10 to the negative 4. All right, I'm going to start with this calculator. So I would do negative and then the log button. There's the log button. And then it was 1.0 times 10. And then there's this arrow. And we were 10 to the negative 4. Negative 4. Press enter. And we get 4. Which makes sense because it's just the exponent. If the number in front is 1, it's just going to be the exponent. If the number in front is not a 1, then we have to definitely make sure we do the calculations. All right, so we can now say that our pH is 4. To get to pOH, well, pH plus pOH equals 14. So if pH is 4, I lost my marker. There we go. So we have 4 plus pOH equals 14. So to get pOH by itself, I'm going to subtract 4 from both sides. Those will cancel. 14 minus 4 tells us that pOH is 10. And I will go ahead and fill in pOH is 10. All right, now to get to this, we can either go up and reach for the exponent, put the pOH as the exponent, 10 to the negative pOH would give us our hydrogen ion concentration. But I always like to start with the number it gives me, just in case I made a mistake down here. I don't want to carry that mistake over here. This number I definitely know is right because they gave it to me. So let's go from here over to here. So our equation for this is that our hydrogen ion concentration, which we have, times our hydroxide ion concentration will equal 1 times 10 to the negative 14. So we have our hydrogen ion concentration, which was 1.0 times 10 to the negative 4 times our hydroxide ion concentration, which we don't know, we're trying to find, equals 1 times 10 to the negative 14. So I need to get this by itself. Right now it's multiplied, so I need to unmultiply. So we'll divide. And whatever I do on this side, I need to do on this side. All right. So 1 times 10 to the negative 14 divided by 1.0 times 10 to the negative, oops, that's a 4, not 14. All right, so let me enter that in my calculator. So I'm going to use this EE button. The EE button means times 10. So I would do 1 and then second EE, and it's the negative 14. I'm going to divide it by our hydrogen ion concentration, which is 1 second, so I can do the EE to the negative 4. And I'll press enter, and you get 1 times 10 to the negative 10th. So 1 times 10 to the negative 10th. So something that I missed out on before, we need to keep our significant digits the same. This had 2, so we don't want to put 1. We want to put 1.0 times 10 to the negative 10. And since this had 2 significant digits, these should have 2 past the decimal. Let me get my red. So 2 digits, 2 digits. And pHs work different because this first number is just telling us what our exponent is. So if there's 2 digits, you need 2 past the decimal. All right, so that filled in that whole chart for us. And then the last 2 questions in the chart, it says color of litmus paper and color of phenolphthalein, and is it an acid or a base? So to determine if it's an acid or a base, we look at our pH. pHs below 7 are acids, so this is an acid, which means our litmus paper will be, well, I wrote it in red because it'll be red. And then our phenolphthalein changes at a pH of around 8 and starts getting pink. This is definitely below 8. So below 8, it is colorless. And that should fill out that first line. Okay. Our next one gives us our hydroxide ion concentration, and we're going to figure out the others. So let's go ahead and start with our left to right. So I know that these 2 on top multiply to give us 1 times 10 to the negative 14. So to get this by itself, well, if they're multiplied, the opposite of multiply is divide. So I'll do this divided by that. Oops, that's not the one I want. There we go. So let me draw a line. That was the first problem. So we have 1 times 10 to the negative 14, and we're going to divide by 2.0 times 10 to the negative 5th. And that will give us our hydrogen ion concentration. Again, I was just taking this equation. I'm trying to solve for this. So right now they're multiplied. So I'm going to divide by this to get this by itself. So these will cancel. But if I divide by this on this side, I need to divide on this side. All right, let me do it with the other calculator. So again, I'm going to use the EE button. You don't have to. There's other ways that you can do exponents. But with the EE button, I don't have to worry about making sure I put parentheses in when I divide. And I'll show you later. I'll use a different button so that you can see that you have to use parentheses. So I would just do 1 EE, and it's the negative 14, divided by 2.0 EE to the negative 5th, and I get 5 to the negative 10th. But remember, that's actually 5 times 10 to the negative 10th. It doesn't show the times 10. It's a shorthand for the calculator, but it's 5 times 10 to the negative 10th. And since I had 2 digits here, when I write this answer, I want to have 2 digits. So 5.0 times 10 to the negative 10th. All right, so let's go down on both sides. So to go down, we need to step on the log. So I'm going to take the negative log of this and the negative log of this. And then we'll check and make sure that these two add up to 14. So negative log, oops, let me do that on this side. Negative log and negative log. This will be our hydroxide concentration. And this one on the left is the negative log. That was our hydrogen ion concentration. All right, so this calculator is going to be a little bit different. So let's start with this one. So the other calculator, I press the log button first. But if your calculator only has one line where there's numbers, so where this one has 2 lines, graphing calculators have several lines. This one only has 1. So we're going to type this number in first. So 5.0 times 10, I'm going to use this EE button, to the negative 10. And now I want to take the negative log of that, so I'm going to press the log button and then the negative. So you almost have to work backwards. So we get 9.30. We had 2 significant digits here, so we want 2 past the decimal. So our pH is 9.30. So we looked at the 1. The 1 doesn't mean this rounds up, so we're just going to leave it at 9.30. All right, let's try it again on the other side. So let me clear this. So I have 2.0. EE is times 10 to the negative 5. I'm going to take the log, and then don't forget it's supposed to be the negative log, so now I need to do the negative. And 4.698, 8 means this is going to round up, so it rounds that 9 up to 10, which rounds that 6 up to 7. So we get 4.70. 2 digits, 2 past the decimal. All right, so let's see. Are these going to add up to be 14? And they do. So we know we did it right. And then let's see, is this going to be an acid or a base? Well, this is above 7, so that means it's a base. In litmus paper, we say basic blue, so this will be blue in litmus paper. And with phenolphthalein, it changes around 8, and it turns light pink around 8, so phenolphthalein would be pink. All right, our next problem gives us a pH. So let's start by figuring out our pOH. pH and pOH should add up to give us 14. So 6 plus what gives me 14? So if I do 14 minus 6, that leaves me with 8. Oops, wrong color. All right, now we can go up. To go up, you need to reach up and put these as the exponent. So 10 to the negative POH will give me hydroxide. 10 to the negative pH will give me my hydrogen. So make sure you guys can see this. Oh, we can't. There we go. So I'm going to do, I'll do it right over here. 10 to the negative 6. Well, that already looks good, right? I don't need to type that in a calculator. That's a number in scientific notation. And the other one, 10 to the negative 8. Now, if you had gotten a decimal for this, like 8.2 or something like that, then you would need to type this in the calculator and see what number it spits out. But 10 to the negative 8 looks all right. 10 to the negative 6 looks all right. This has 0 past the decimal. So when we write it, we don't want to put any significant digits. So you would just put 10 to the negative 6. And for this one, you would just put 10 to the negative 8. All right, is this going to be an acid or a base? So 6 is below 7. That would be an acid, which means this would be red in litmus paper. It's below 8, which is when phenolphthalein starts to change. So it would be colorless. All acids are colorless in phenolphthalein. Weak bases are also colorless, but right around a pH of 8, they change. All right, the next one gives us our hydroxide ion concentration. I'm sorry, our POH. So let's figure out pH first. I know these two add up to give me 14. So if I subtract 11.2 on both sides, that's going to give me 2.8. So these two add up to give me 14. And I kept one digit past the decimal for both, which means I'm going to need to write one significant digit for both of those up there. All right, let's go ahead and go up. To go up, we need to reach up and put these as our exponent. So I'll do one on this calculator and then I'll switch over and do one on the other. So 10, I'll go ahead and do this one. 2, I'm going to use a different key this time. So let me use the 10x one. So there's a 10x right there. Oh, I forgot it goes backwards. So you actually type in the x first. So I have negative 2.8, but I want that as the exponent. So second, and then there's the little 10x up there. Oh, that's not right, sorry. There we go. I think I didn't put the negative in the first time. So negative 2.8, and then we did the 10x of it. So it gave us a number, but it's not in scientific notation. So we can either just write that number down Remember, we only want one significant digit, so the zeros aren't going to count. So this first one, I'm going to look at the 5 and see that it does need to round up. So you can either write 0.002, or we can change that to scientific notation, move this over 1, 2, 3, and this would be 2 times 10 to the negative 3. See how my exponent is close to this? Oh, I see. You can't really see. There's a glare. There we go. All right. Let's do the next one with this calculator. So I'm going to do 10 to the negative 11.2. Let's use a different function on here as well. Let's use, there's the 10x on here. So for this one, you type it in first. The calculators with the single lines, you have to type it in second. So let me zoom in so you can see. So you see that 10x above there. So I typed in 10x. It got me this with the caret. And then we wanted negative 11.2. So negative, and then 11.2. And then that's going to give us, and then this one spits it out in scientific notation. Because since it's the negative 12th, there would have been 11 zeros in front of here. So again, we want one significant digit. So the 6, 3 does not make it round up, so I'm just going to keep the 6. 6 times 10 to the negative 12th. pH is below 7. This would be an acid, which means litmus paper would be red, and phenolphthalein would be colorless. All right, we're about at the halfway point for this. So I'm given my hydrogen ion concentration. Let's go ahead and go to hydroxide first, because I think that is the more difficult one for you guys to do. Remember, these multiply to give us 10 to the negative 14. So to isolate it, we need to divide by this. So I'm going to do 10 to the negative 14 divided by 3.3 times 10 to the negative 12. So let me type that in here. Looks like you don't have any glare this time. So let's do this 10x button again. 10 to the negative 14 divided by, so now if I'm using the 10x button, I need to make sure I put the bottom in parentheses so it knows that this all goes together. This is all one number. 3.3 times 10 to the negative 12. Again, since I use this times 10x instead of the EE, I have to make sure I put that whole bottom number in parentheses so it knows that it all goes together. And I get 0.003. Let's see, I need two significant digits. Oh, yep, two significant digits. So 30. Let's look at the third digit. It's a 3, so it's not going to round up. So I would write either 0.0030 or 3.0 times 10 to the negative, because it's smaller than 1. Let's see, 1, 2, 3. If I move it 3 spots, that's going to get me a number between 1 and 10. All right, now to get to these, we need to go down so we can step on the log. So let's start with going down here, and then we can just go left to right. So I need to take the negative log of 3.3 times 10 to the negative 12th. So negative log of 3.3 times 10 to the negative 12. So you would just type negative log 3.3. Do we have glare? That's better. Times 10, and this time I'm going to use this caret, to the negative 12. We need two significant digits, which means 2 past the decimal. So 48. Look at the 1. It doesn't need to round up, so I'm going to put 11.48. All right, now we know these add up to be 14. So these should add to be 14. So if I subtract 11.48, you would get, so 14 minus 11.48, 2.52. We're going to keep 2 past the decimal because we started with 2 significant digits. All right, so pH above 7. This is a base. Litmus paper bases are blue. And in phenolphthalein, since it is also a pH above 8, which is when it starts to change, so this will be a dark pink or almost red. So we'll still put pink. You really just need to know pink or colorless, but this, since it's higher up, would be a very, very dark pink. Feel free, if you think you're getting it, to just skip ahead and get the answers, but I want to keep working them all out for our people who do need the help. All right, let's go ahead and go down first. So to go down, we need to take the negative log of our concentration. Let's do it in this calculator. So remember, this one works, you almost enter it in backwards. So if you have a calculator that only has one line, you enter it in backwards. So I'm going to do 4.00 times 10, and I'm going to do that yx, the negative 9th. Whoops, I forgot backwards. 4.00 times 10. And then I press that yx. That'll give me my exponent to the 9, but we want it negative. All right, so that is 4.00 times 10 to the negative 9. And I want to take the log of it, but it was actually the negative log, so then negative. So you kind of got to work backwards on these calculators. But then let's check and make sure it makes sense. So if it was 1 times 10 to the negative 9, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9. But we had 4.0 times 10 to the negative 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a little bit bigger than this one, right? Which means that if it's 1 times 10 to the negative 9, then our POH is 9. But since this is a little bit bigger, the POH should be a little bit less than 9, because since these are negative numbers, the bigger it is, the less negative we're getting. So since we got 8.397, let's see, we need 4 digits. So 397 are my 4, but after that 7 is a 9. 9 means I have to round 7 up to 8. So 8.398. So it's a little bit less than 9, because if it was 1 times 10 to the negative 9, it would be 9. But since this is a little bit bigger, this will be a little less. All right, now I think it's easiest to go left to right. These should add up and be 14. So if I do 14 minus 8.398, that should give me the answer. So 14 minus 8.398 gives us 5.602. So again, since these added up to be 14, I did 14 and subtracted this to get this one. All right, now we could continue going up, but what if I made an error along this way? I've now done 2 calculations to get to this number. So I don't want any errors to carry over up to here. So I'm going to use this number and go left to right. Be very careful if you're going all the way in a circle. By the time you get to the end, you've done multiple calculations. And so I rounded here, and then that caused this to be rounded differently. So let's go from here to here. So remember, those 2 are going to multiply to give us 10 to the negative 14. So the opposite of multiply is divide. So I'm going to do 10 to the negative 14, and I'll divide by this. All right. I'm going to go back to using the EE button. So 1 EE to the negative 14 divided by 4.00. EE is the same as times 10, and then 9 to the negative. All right, so it spit out this number. 0.0, how many zeros? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then 2, 5. So if I want to write that in scientific notation, and remember we need 3 digits, so even though it didn't give me a number after here, that's probably because it's 0. So we can write 2.50. That's a number between 1 and 10, so the decimal would be there. So we need to move it 1, 2, 3, 4, 5, 6. Whoops, I don't know why I wrote 16. All right, and pH is below 7, so this is an acid. Acids turn litmus paper red, and phenolphthalein would be colorless. All right, starting with pH, so let's go ahead and go to pOH. So 14 minus 10.5. Since these add up to be 14, we're figuring out what is missing. So 14 minus 10.5 gives you 3.5. 1 past the decimal, 1 past the decimal. To go up, we're going to reach up and put it as the negative exponent. Same over here. To go up, we're going to reach up and put it as the negative exponent. Because there is a decimal here, we don't want to just write this number up here. You want to actually put that in a calculator. So if I do, so either I can do 1 times 10, so that EE to the negative 3.5. Ooh, did it let me do that? 1 EE 3.5. I can't tell if it's putting a decimal in there or not. No, it won't let you do that. See, it won't even let you type that number in. So for this one, you'll have to either use the times 10 button up here, or you'll have to use this one. So let's do 3.5, make it a negative, and then I'm going to use this 10x button. So second, 10x. That means that the number I just entered is the x. And we get 0.0003. We want 1 significant digit, so look at the 1, doesn't round up, so that's what you'd get. In scientific notation, you would write it as 3 times 10. If I move this over 1, 2, 3, 4 spots, so negative 4. And this is a little bit than 1 times 10 to the negative 4, which is why the number is a little smaller than 4. All right. Let's do this one. Reach up and put that as the exponent. So 10, and I'm going to use the caret. Ooh, is that typing? Yeah. Negative 10.5. And you get 3.16227766 times 10 to the negative 11. We only want 1 significant digit, so I'm just going to keep it at 3. So 3 times 10 to the negative 11. All right, pH is above 7, which means this is a base, which means in litmus paper it would be blue. In phenolphthalein, it would have already changed and been pink. All right, 2 more. All right, so I have my hydroxide. Let's go ahead and get pH. So 14 minus 2.3. 14 minus 2.3 is 11.7. So again, these should add up to be 14. So if these add up to equal 14, I just subtracted 2.3. That means these cancel, but whatever you do on that side, you do on this side. And that got me 11.7. All right, again, we need to both go up. We're looking for 1 significant digit since we have 1 past the decimal. So 2.3. But remember, when it's a negative exponent, not that one. 10 to the negative POH. So I put 2.3. Let me make that negative. And now I'm going to put that as the exponent using, it says 10x there. So second, and we get 0.0050. The 0 means we don't round the 5 up, so 0.005. Or in scientific notation, move the decimal over 3 to get a number between 1 and 10. 5 times 10 to the negative 3. Your exponent shouldn't be more than 1 off from the pH or POH. All right, 11.7. So I'm going to do, there should be a 10x button on here. There is. So second, 10x, 11.7. Oh, I forgot to do negative 11.7. And I get 1.995262315 times 10 to the negative 12. I only want 1 digit, so I look at the 1. The second digit is a 9 though, which means that 1 rounds up